Okay, I think we can start. Welcome, everyone. This is my favorite time of the day because we are having our lightning talks. In the past, we were also doing some signups during the event, but we were lucky enough that we had a lot of submissions for the lightning talks today. So we are not getting any signups on the spot. Um, I will just introduce it's called lightning talks, which means that we really want to have like short on spot talks on many different topics. We have today six presentation, and I'm happy to introduce our first speaker. It's Bex or Brian Exelbeard, who will talk about the 139 euro monitoring stack. So Bex, stage is yours now.
Thank you. And as she said, I'm Brian Exelbeard. I'm Bex. I work for Microsoft doing Linux, and this talk has nothing to do with that. I also want to point out a couple of context details. The 139 euros in this title, it's not a typo. That's actually what my monitoring budget was, and I wound up spending a lot less on this project. And lastly, the context for all of this is a critical piece of load-bearing infrastructure that I work on that simply cannot have fault. You're all familiar with it, of course. It's puzzlesecretary.com. So puzzlesecretary.com is a social games sharing site that creates leaderboards for folks. And you know how gamers are, things have to be running. But I also need to make some confessions. It's not running on a cluster. It's actually just one little Azure VM running Flatcar, bravely facing the world without a service mesh. But it needs monitoring. So we learned in the keynote this morning, how do you do monitoring? Well, you need logs and Prometheus and Loki things, and you need dashboards and traces and something called RUM that was on one of those slides. Not the good kind, apparently. You need a way to blow up your phone, and you need to spend a weekend wiring all of these pieces together and write a small galaxy of YAML and watch your soul leave your body. I love all of you who do this for a living, but do not want. I was trying to figure out if there was a better way. And a few more confessions. I don't look at dashboards. I don't have a monitor in the corner of my office that shows me traffic stats or usage that I check every morning. I literally never open the dashboards. So I need a system that's going to yell at me, not one that's going to wait politely to be consulted. And so I found a solution. I installed Home Assistant. Yeah, that Home Assistant. The 139 euros, it bought me this HA Green that you see here. It is pictured here installed in my data center. Now, Home Assistant is not crazy. Like, it knows how to blow up my phone. But Home Assistant does something no other monitoring system can. It can haunt me. Home Assistant sets it up such that nothing says Sev1 like your living room being disappointed in you. So this isn't actually crazy. Home Assistant has a time series database. I know this because it monitors all of the temperature sensors in my home. And what is CPU load but like temperature for nerds? It has graphs and dashboards that I also don't look at for Home Assistant reasons, but I know that they do exist. I happen to use MQTT to send all the stats from my app to it. My Home Assistant already does MQTT because I have a light that was annoying and insisted on using MQTT. It does alerting and notifications. We saw that in the pictures of my phone getting blown up and me being threatened with calls to my mother. But interestingly, it's also a piece of infrastructure I can rely on because it's on my Tailscale VPN because I don't expose anything to the internet because I'm a reformed developer, not a security person. And it's always on 24/7 because if it's not, I have to turn on the lights in my house using a switch like an animal. So that's what I used. Now, this isn't crazy. There are dashboards, as I said. I don't look at them, but it is nice to have a curve whenever I need to see if something went wrong and what was going on right before that. This is an example of one that I've got. This is the whole architecture that I've got. My application runs in containers on my VM. There's an extra container from our friends at InfluxDB called Telegraph that grabs system stats as well as custom stats about my application. spits those out as MQTT messages over my Tailscale Telnet, where they land in my data center. Home Assistant logs them and then decides if it needs to haunt me. That's it. That's the whole stack. Now, I want to really kind of bring this home with this isn't actually, I set out to do something crazy to make a lightning talk. I got here by asking myself 3 questions. What do I already have, already know, or already pay for that can solve my problem? How can I not have to bring my day job home for my side project? My goal is to play games and improve Puzzle Secretary, not build a platform for my platform. So this lets me stay focused that way. Home Assistant provided all of the pieces that I needed here, and everything works great. I'm getting, I think, the hook over here, so I will be quiet and say, I'm Bex. The slides are at this link. Thank you very much.
Hi, everybody. My name is Mohammed from Mirantis. And the next 5 minutes, I want to convince you that we, as the CNCF community, are paying attention to the wrong slice of the AI market, which is the big hyperscalers and the AI frontier labs. But I believe that the future of AI on Kubernetes will be a lot smaller, more dedicated, and more cost-effective. So every AI headline this year, or even last year, to that matter, sounds like one of those. 1,000 clusters and big data centers, $10 billion data center, and the new model at Anthropic and its performance topping the charts, et cetera, et cetera. However, all of these are, even though they are important, they are impressive, and the use cases do make sense, they are probably not for every one of us out there. So if you look at some of the studies out there, the consensus, and there was a specific research at Gartner about this, estimate that at least 65% of AI compute will be for inference by 2029. In my previous talk, I also mentioned another figure, which is that already this year, in 2026, 44% of enterprises are allocating 65 to 100% of their AI budget for inference. So I think we can easily say that AI inference will be major in the next couple of years. And actually, it does make sense, because if you look at training against inference, it's the kind of make once, use many, right? So you train your model once, and then you use it multiple times or even millions of times if you look at AI frontier labs. So you can think about the same approach for smaller scale, right? So who are the companies that will need AI inference, these 44% or more, that are already on Kubernetes? But basically all of them, right? And some have very strict needs in terms of data handling and where the data goes, etc. So you can talk hospitals, banks, factories, public sector, everything. However, we speak a lot, or at least in these bigger events such as KubeCon, etc., we speak a lot about AI ML, like machine learning and particular training. So many of the talks assume that we need multi-tenant GPU fleets and 100K GPUs, but this is not necessarily the case. The CNCF has already everything that you need to answer to the AI inference needs. And there are multiple projects from sandbox to matured ones, etc., graduated, that will provide you with the results. Some of them are, and I mentioned in the previous talk, Cluster API for infrastructure, Hami, Kaito, LLMD, and others, many others. So what do these unlock for you? These make AI inference on commodity hardware and consumer hardware really accessible. And it offers you scalability, it offers you efficiency. For example, multiple use cases mention a 10x improvement in GPU utilization using HAMI, for example. So this will achieve lower infrastructure costs and all of that on-premise. So let's stop optimizing for OpenAI and Anthropic and start optimizing for everyone else. These frontier labs will be fine, and the 90% of enterprises will need to appropriate this new stack to do actual production-grade inference on-premise. So the future of AI on Kubernetes will be small, shared, and everywhere, thanks to things like Cluster API, HAMI, Kaito, etc. So let's build this 90%. Thank you, everyone.
Hello, everybody. My name is Vladimir. I work in the Red Hat as Senior SRE. And today I want to show you what Kubernetes native CI looks like in practice using a project called Conflux as a real-world example. Just a couple of words about what Conflux is. It's an open source CI/CD platform for the full software delivery lifecycle, which is fully built on CNCF and open source projects like Tekton, Buildach, Sixtor, Argo CD, and Kubernetes, of course. Anyone can use it, download, install, and contribute. So how does the build actually happen? You have your Git repo, it sends a webhook, and from that point, everything is just Kubernetes resources. A pipeline run is created, which is basically a pod running your build. The image gets pushed to a registry, no magic, no proprietary engine, just Kubernetes is doing what Kubernetes always does. And this is really the core idea I want you to take away. Most CI systems run beside Kubernetes. For example, Jenkins instance serves somewhere, a GitLab runner on a VM. But what if your CI actually run on Kubernetes as a native workload? Every build step becomes a pod. Your pipeline is a CRD. You can kubectl get your builds. You get scheduling, RBAC, resource limits, observability, all for free because it's basically just Kubernetes. Here are several patterns. First pattern, pipelines as code. Your pipeline definitions live right in the repo in a Tekton directory. A Git push comes in, a CEL expression decides if this change should trigger a build, and the pipeline run is created automatically. There is no CI server to configure. Your cluster is your CI. And this works with GitHub, GitLab, etc. out of the box because it's a CNCF Tekton project, not a vendor specific. Second pattern, using OCI artifacts to pass data between tasks. In traditional CI, you'd use shared volumes, shared PVCs, which sometimes create bottlenecks, and can be tampered with. Here, each task is an independent pod. Data goes through the OCI registry, immutable, content addressable, just like container images. OCI, the same image format you already use for your applications, now carries your data builds too. Third pattern, hermetic builds. The build runs in two phases, actually. First, you download all the dependencies with the network access. Then the actual build happens with the network completely cut off. If something tries to pull an unexpected dependency during build, it simply can't. On the top of that, Tekton Chains, another CNCF project, automatically signs every build with cosign and generates supply chain levels for security artifacts. You get supply chain security without changing a single line in your Docker file. Fourth and the last pattern, testing and releasing the whole application together. When a component builds successfully, the system creates a snapshot, a point-in-time record of all your component images. Integration tests run against that snapshot. The policy gate checks signatures and provenance, and on success, the release pipeline promotes it to production. Fully automated from Git push to production, no human clicking deploy. So to wrap up, these 4 patterns aren't specific to Conflux only. They're Kubernetes native patterns built on CNCF projects that anyone can adopt. Pipelines as code with Tekton, OCI artifacts for everything, hermetic builds with thick-store signing, and snapshot-based integration testing. The bottom line is CI shouldn't run alongside Kubernetes. CI could be Kubernetes. Thank you. So you can find the QR with the presentation and some useful links.
Okay, hello everyone. I'm Martin from Tieto, and I'm also a member of Cloud Native Telecom Initiative, which is crossroad between telco sector and shifting telco sector into cloud native world. And this is the test suite that I will talk about today. So this will be more return back to cloud native basics. No fancy AI talk from me, sorry. It's about cognitive basic, and we still need to take care about basics, right? So the basic question from me, is your application cloud native? And how you know that, actually? One may say that, okay, my application runs on Kubernetes, so it is cloud native, right? Well, not necessarily. Going into extreme, you can take your monolith application from bare metal, and you can make it running in a container, and it runs under Kubernetes, right? Not really cloud native. I think you would agree with me. So this is kind of thing that we take care of. Additional examples, if we want to find anti-patterns of cloud nativeness, for example, stateful traps, right? You can have host path mounts, readable host path mounts, dependency on work node, and you cannot evict your pod, move it elsewhere. One example. Additional example, the exit of your services or pods in case that Kubernetes needs it. Your service needs to take care of handling of sick term, right? Gracefully and shut down your application. Or the visibility of errors in case that something bad happens in your container. Kubernetes needs to know that, and therefore we have probes. You need to probes that set up. So those are examples that you need to follow in order to be cloud native. So you can work out such list of cloud nativeness, right? And take care that your application follows all of them or most of them. But best if there is already something existing and automated. And yeah, indeed it is. And this is a Cloud Native Telecom Initiative test suite, which implements that. Why from telecom? Well, actually, historically, telecom is a sector that is quite slow to progress and slow. Oh, it was also slow to with going to cloud native, and it still has troubles with having telecom applications adhere to best practices of cloud nativeness. So therefore, we came with the test suite that helps with translation to cloud nativeness. So it's open source project under Linux Foundation Networking. We have more than 80 such tests, which is I think quite a lot. And it's targeted to telecom-grade applications. And actually, any application outside telecom can benefit from that, I think. So examples, you can have here examples what we test for configuration, resource limits, unit resource limits, or you need for volumes, if you need stateful services, you need elastic volumes, for example. We check that. Or from security world, big topic, right? Security. You cannot use root users under your containers. That's a bad and security anti-pattern. And go on and on and on. How to run it, how to use it for your applications. 3 simple steps. You can have it in 15 minutes, actually. You need to write simple YAML, which describes target of your application, Helm repository, for example. First step. Second step, install it using CNTI test suite. And third step, run the test and get the results. 1, 2, 3, simple as that. And feel free to use it. We are a Vibrant community, and we are here to support you in case you need to help with running of test suite on your application and proving that your application is really cloud native. And we have set of most important 18 tests, which you can start with, and you can get GitHub badge if you comply with that. Yep. So connect with us. Thank you.
Thank you so much.
Hey everyone, so my name is Daniel Grigoryev. I'm a senior software engineer at Mirantis, and today I'm going to show you something which is not related to my work entirely. It's more of a hobby project which I was developing for a couple of years, and there are some use cases you may utilize this in. So I'll fire up the demo. As you can see, this is a recording of how it works. What I'm going to do here is create a simple cluster. Any Kubernetes cluster will do. And when it's done, you can, for example, imagine a scenario. This cluster is your CI. In the CI, you're testing some workloads, you're deploying some things. AI, not AI, anything like development workflows, and you run end-to-end test on them. You want to verify that your CI is passing. That's easy. Everyone is doing this. But what if it fails? Typically, you forced to write end-to-end tests, to implement all the collection logic, to know what the failure came from. But imagine a scenario. You have a very complex infrastructure developed for this, like air-gapped, I don't know, some vSphere, private cluster, anything else. You basically need to know what happened with your CI without reproducing this as fast as possible, as you want to fix this. And so this tool, what I just did, I just fired it up, and it collected all the cluster states, like all the resources, everything you have, which is not uncommon. Everyone is doing this in their production, in their scenarios, in your CI. But what the ClassGather allows you to do is that once you collect this, and actually in this scenario, it collects this whole cluster state into an OCI image. So it's publicly available for you in the registry, and this registry later serves as a file system. So once it's collected, you're getting some information about the cluster. As you can see, some things inside of that, namespaces, cluster resources, versions, APIs, all the logs, all the pods. In the moment of failure, you get all in this archive. You can store it in zip, you can store it somewhere, you can store it in image, and give to your colleague to debug. But what if your colleague is an AI agent? You don't really need to look into this thing, because AI agent can analyze the failure for you. Not only logs, not only the states you written in end-to-end test, but the whole cluster state, events, logs in the background. Images there, it's available. And as you can see, I'm starting here MCP server, which ClassGather provides. And I'm giving a simple task of explain me what that cluster contains. Maybe some failure in it. Something broke, I don't know, figure it out. It may be automatic task. It fires overnight. So in the morning, you wake up and you get the summary of your failures in CI. You can go and cross-reference them across multiple scenarios. Like you have a nightly job which failed for a week. You never noticed this. But now you have all the stored snapshots of your clusters at the moment of failure in your image registry, and you can just basically delegate to AI to cross-reference, to find the issues, and, well, tell you what's going wrong. And what's happening here, it starts to run from the archive. And what it starts is an API server. So it's fully, well, not fully, it's a handwritten API server in Rust. Very simplistic one, focusing on data plane. I didn't go really mention the whole thing. It's not production ready. It's just a specific API server for debugging things. And you run kubectl, KNNS, everything sees this as a real cluster. It has all the information, even more than you may imagine. For example, you can specify to pull some node level logs. It runs to the debug pod, starts those executables on your host, collects the logs, and you can see them from the snapshot as served in this scenario. So as you can see, those some outputs that like Codex store, that's a real cluster, but it's now gone. You don't spend money on this. Your CI is now long gone. You don't need to worry about this. Everything is stored. Everything is ready for you to debug, either human or AI, as in this scenario. So yeah, feel free to come tomorrow. I'm going to have a larger talk about development of this project, some discoveries since it's API server in Rust, maybe some interesting, non-interesting details about how it works, what things I faced, what API server, if you focus this on a high-level perspective in Kubernetes, means, what things don't scale, you cannot create or recreate, and you are basically vendor locked in, and how easy it actually was, even though it was a project which was like Rust, you know, it's a complex one. So yeah, as you can see, the result of this, it tells me that it has engines, there are some pods running, something that's pending. You can follow up with this and like explore further, because AI works much better if you go through tool calls and narrow context. It knows what to go next if you have a specific context in mind. If not, you have always a snapshot as a file system. You can go through all the files by yourself. So yeah, that's it. Thank you very much.
Dobrý den, mé jméno je Lenka Kargerová, baví mě automatizace nad infrastrukturu a to mě občas dostává do hodně zajímavých situací. Tak možná mnohem zajímavější, než bych já sama chtěla. Komu z vás se někdy stalo, že vás mezi 1. a 3. hodinou raní zbudil Slack nebo PagerDuty kvůli nějaké aplikaci, která nefunguje? Jo, děkuji. A komu se stalo, že při tom debugování zjistil, že ta aplikace sama o sobě funguje a že problém bude asi někde úplně jinde, třeba na síti, v síťové vrstvě? Jo. Díky, děkuji. Děkuji za přiznání. Já jsem tehdy byla poměrně začátečník, takže mi nezbylo nic jiného, než udělat radost našemu síťaři a zbudit ho v noci taky. A náš síťař mi říká, no ale hele, ty tam nemáš herpinning. Říkám, co to je, že? A zjistili jsme, co to je, síťař mi pomohl to nastavit. Šlo o to, že se nám data, která patřila do interní sítě, pěkně putovala ven do internetu přes venkovní. Tak já jsem chtěla po Gemini, aby mi nakreslila obrázek mě, ale ona nakreslila toho síťaře. No, dobře. Takže data putovala vlastně venkem, ta se patřila do vnitřní sítě, pěkně přes firewall, že jo. Měli jsme krásně přetíženou síť a proto nic nefungovalo. Spoustu let později jsem se potom dostala do situace, kdy ale ten herpinning jenom tak jednoduše nastavit nešel a kromě toho v tom prostředí byla spousta dalších jiných problémů. A hledání toho řešení mě dovedlo právě až k DNS Split Horizon. A ten klidný spánek mi zachránilo to, že jsem se ho naučila, ale ne úplně to tak dopadlo s tou implementací. Vysvětlím proč. Nejdřív ale co to vlastně je ten DNS Split Horizon. Někdy se taky říká split brain nebo split view a můžeme si to vysvětlit třeba na příkladu, kdy jste doma a potřebujete objednat balíček pro vaši přítelkyni, manželku a jak popíšete, kam jej doručit. Uvedete adresu, jméno, příjmení, obec, ulici, číslo popisné a když to jde dobře, zazvoní vás kurýr a doručí balíček. Ale v podobné situaci, když jste třeba doma, máte děti se přijdou a ptají se, hele, tati, kde je maminka? Jako, co jim řeknete? Ulici, číslo popisné, pošlete zvonit na zvonek? Ne, že? Řeknete mi, já nevím, na zahradě, v pracovně, kde tak jako se doma běžně vyskytujete. A to je ten Split Horizon. V podstatě na jeden podobný dotaz ten DNS server vrací 2 různé odpovědi podle toho, kdo se ptá. Tak a teď proč vám to může zachránit ten spánek? Za prvé, nestane se vám to, co se stalo mně, že budete posílat ta data, co patří do interní sítě venkem, nebudou zvonit na ten zvonek zvenku, nebudou vám přetěžovat firewall. Druhá věc je bezpečnost. Když budete vracet jiné DNS záznamy pro ty, kdo se ptají zevnitř a jiné pro ty, kdo se ptají zvenku, nevystavíte vám spoustu důležitých informací. Nemusí nikdo vědět, na jaké interní IP adrese jede vaše devové prostředí, nebo kolik těch devů máte, jak se jmenuje váš password management a kde je. A ve třetí řadě je to nějaký komfort pro ty dané uživatele. Prostě se nestarají, zadávají adresu a hotovo. Takže to vždycky by se mohli takhle krásně dobře spínkat, ale ono to má své úskalí. Co by se mohlo stát, že? Tak jedna věc je DNS cache. Máte člověka, který pracuje v kanceláři, třeba vývojáře, všechno mu funguje, zaklapne notebook, jde domů, doma notebook otevře, protože si z toho ještě něco rozmyslel, na co si vzpomněl, chce odeslat nějaká data, ono mu to nefunguje, protože mu zůstaly nakešované ty interní doménové záznamy. Takže tam má teď nějakou vaši IP adresu interní a na jeho domácí síti v lepším případě teda na to nic neodpovídá, samozřejmě. A druhá věc je potom nějaké debugování, které je potom hodně složité. A věta od uživatele, mně to nefunguje. Potom dostává úplně jiný rozměr, protože jde o detektivní činnost. Při tom debugování zjišťujete, odkud pracuje, jestli je v interní síti, jestli někde ve vlaku nebo kdekoliv jinde. Takže co s tím teď v roce 2026? Naštěstí se to dá všechno řešit, dá se to řešit jinak a docela dobře. V první řadě je potřeba se zamyslet nad tím, co ve skutečnosti doopravdy potřebujete. Vesměs vám bude stačit privátní subdomény, které budou dostupné jenom za VPN-kou. Budete na to mít privátní DNS server a ten bude odpovídat jenom za tu VPN-ku. Je to celkem v pohodě, ať používáte WireGuard nebo cokoliv jiného. Při připojení v tom klientovi nastaví ty správné DNS servery, je to vyřešené. A je to mnohem bezpečnější, že jo, samozřejmě. Druhá věc, spousta zaměstnanců vůbec nepotřebuje třeba ani tu VPN-ku. Typicky nějakým obchodákům, aby se dostali do CRMka, stačí třeba nějaký Zero Trust tunel. Jo, máme dneska Tailscale, HashiCorp Boundary, Cloudflare Tunnels. Krásně se to dá nakonfigurovat, je to pro vás mnohem jednodušší a řeší se to bezpečně elegantněji na aplikační vrstvě. No a ať už zvolíte jakékoliv řešení, tak co doporučuji rozhodně je vyhnout se takovému tomu ClickOps. Nikdy nic neklikejte ručně. Spravujte veškeré vaše DNS zóny výhradně přes infrastrukturu jako kód. Tak. A to je všechno. Když to dodržíte, já doufám, že se vám bude dobře spát. Díky.
Good evening. During this last short talk, I'm going to take a quick journey about how to design a system for getting large data. So raw data is stored on storage and needs to be downloaded by many users. When I say raw, I am trying to emphasize actually that it's in a large size, not necessarily maybe in terabytes, but let's say 50 gigabytes. So it is collected, stored there, and you cannot share any credentials. You cannot mount the object storage as a volume or something, and it needs to be accessed securely. So here's an idea. Why you just not serve over HTTP, right? Point a URL at the data on the storage, and then users can download through your infrastructure. Well, that's actually where the problem lives, in your infrastructure. When we are talking about, when we say the infrastructure, we are pointing at the API gateways, proxies, load balancers. But why that will be a problem? Because the connection will be killed, not by a lag or something, not because we have like a low speed, but by just design. So first of all, each system we are referencing here, like the proxies, API gateways, load balancer, has their purpose. They serve an each purpose, and they have hard limits. And one way or another, you will hit those hard limits, and it won't be able to possible to actually even overcome them because they are not negotiable. You might be saying that, well, I can watch videos on the internet without any issue, right? Yes, especially when you are streaming or when you are actually watching a stream. There are different protocols, one of which is UDP, one is TCP. So UDP is the type of protocol that fire and forget. So package not necessarily will be acknowledged that they are received. So in that case, that will be fine if you are streaming a video, which is the reason sometimes you see some drops in the connection, but you don't understand the person. And that's completely fine because that's actually one of the trade-offs. But HTTP under the hood uses TCP, and every package must be acknowledged. And when it comes to TCP, we have some limitation. We cannot have that much large packages. Top of that, HTTP overall is not going to is not support to download like a gigabyte of data, maybe megabytes. And when you wanna actually download the file, the tools we are using already in these days opens multiple connections. So each connection will go through the system, the infrastructure. And when it happens, what will happen? Well, authentication, authorization, basically refreshing the tokens. So eventually there will be issue on your side. You will create the bottleneck. So as I have just mentioned, tools and technologies we are using today already actually have the ability to split into chunks and request like some range of bytes. And then you can actually have accumulate everything on your local environment. So this is already happening. But the problem is about overcome the bottleneck. So instead of going through the infrastructure, what we can do, we can maybe receive a pre-signed URL from directly the object storage, which means we don't need to actually authenticate, authorize, token, refresh. We don't need to deal with any of those, and we will do it only one time. What will happen? We will get the pre-signed URL, bypass to basically the sort of the infrastructure. So with this approach, we will be able to overcome the issue that limit, and as well as also we will be able to download the file if there is a connection, for example, drops. So basically, that's it. This was actually a quite beginner friendly. For those of you who are interested in actually building a foundation, I believe this might be, hope you find this useful. Thank you.